And welcome to the Daily Space Weather Show. Exciting stuff coming at you. Literally coming at you from the closest star. We've got some disparities in terms of the speed of this CME. Some folks thinking it's going to arrive a lot earlier than others. We'll get to it. Here at the Smash News Network, least busted name in news, congratulations on realizing the channel exists. Just bringing you the world's most comprehensive daily space weather content and most detailed solar imagery. And it's a pretty good time to be doing it, wouldn't you say? We had an X-class solar flare early this morning. And a lot of solar material is now blasted toward Earth. We're expecting it to arrive sometime on the 26th. Other folks are thinking it's going to arrive a full day earlier. I'm not so sure on the speed. But it is certainly headed in Earth's direction, almost perfectly earthly directed. Don't be surprised to see as much as a G3 level geomagnetic storm, KP7 or KP8 could even happen. So we're going to come back to this here momentarily, but there's a little tidbit into, what we're talking about here. So, and let's briefly take a look at the events associated there. There is an X-class flare in there from Sunspot 3615. That is an SDO 94 angstroms video. And it's just for today. That's March 23rd to date. And yes, my microphone is full of stars. All right, so let's move on here to see what's going on Earth. And once again, an incredible scene unfolds in the country of Iceland. So we actually are seeing some aurora there, believe it or not. You can see some pink aurora happening there. Let's see if any of the other images show any better aurora. They were pretty bright just a minute ago, but of course you've got this insane scene here at Sundnukar as new real estate gets created in Iceland. Ah, yes. New real estate. Good times. And yeah, we saw some aurora there, so there we go. There we see some green aurora showing up on that image there by Langahryggr. All right. So yeah, of course, volcanoes are erupting on Iceland. It's been steady for the past 24 hours on the Reykjanes Peninsula. Except the Blue Lagoon's employees have gone home. So somebody went home sick also because they breathed too much sulfur dioxide. Abiko's also erupting, although volcanic ash not identifiable in the satellite imagery. Ibu, Semeru, Merapi, Popocatépetl, Santiaguido, Fuego, Sangay, and Sabancaya all erupting. And the 7-magnitude earthquake drought almost ended, folks. This one could be a foreshock, and if it is, well, it could be the predecessor to a large event. Again, the 7-magnitude earthquake drought continues, and that last 7-magnitude earthquake was barely a 7-magnitude earthquake. So here's the largest of the past 24 hours, just north of Chambri Lake in Papua New Guinea. So that was a 6.9 magnitude quake. That is some significant shaking in the western Pacific island nation of Papua New Guinea. Yes, Papua New Guinea. Anyway, these are the quakes of the 5 and greater magnitude for the past 24 hours. Let's hope they're not foreshocks. Remember, any earthquake can be a foreshock, even a large one. There's a 5.3 at Indonesia, east of the Papua New Guinea quake. I mean west. And then Papua New Guinea. That 6.9 occurred at 2022 Universal Time this evening. And then, of course, an aftershock there, no real surprise. And before we get back to that... No, let's get back to that. That's better. Yes. Yes. The 10.7 centimeter radial flux now up to 209 solar flux units. So Solon.info needs another update there. And for you new viewers, the radial flux is the data set proportional to sunspot number. So high radial flux means high sunspot number. High sunspot number means high radial flux. The radial flux is proportional to the solar cycle's activity. So at solar minimum, we see as low as below 70 solar flux units. At solar maximum, over 200 solar flux units. Again, there's the 1 year graph. The black line represents the radial flux, the red line, the sunspot number. As you can see here, NOAA is expecting the CME impact. I think that's the CME impact later there. So I believe NOAA agrees with us that it's going to arrive late in the day on the 25th, early on the 26th. I'm on board with that. I think the activity there on the 25th, Monday, is actually a coronal hole high-speed stream. So we are expecting the possibility of some interaction there. So it all depends on how long the coronal hole high-speed stream lasts. So we expect, like NOAA, once again we agree here that the coronal hole wind stream will arrive early in the day on Monday, possibly even late in the day tomorrow, and then late in the day on Monday into Tuesday morning, expecting the major CME impact, could see as much as a KP8. Now the ESA site has not updated this yet, so we don't see ESA forecasting. Oh, now wait. 24, 25, 26. No, ESA agrees with us as well there. So expect the CME impact early in the day on the 26th and the coronal hole high-speed stream late in the day on Monday, March 25th. By the way, if you enjoy the world's most comprehensive daily space weather content, don't forget to press the like button. If you're new to the channel, do yourself a favor and subscribe. Get the world's most comprehensive daily space weather and most detailed solar imagery delivered right to your YouTube feed. If not, visit the links below the video. There's all kinds of other ways to get involved with the channel, so please do. Visit the links. Help increase the probability that the channel will continue to exist. These are the past 4 hours of Earth's magnetic moment from space, and we have an ongoing geomagnetic unrest or mild geomagnetic storm condition continuing here. So now this one looks like it could be a coronal hole high-speed stream, so we may see an early onset for that. That could also explain why we saw the most significant proton event of the cycle. So certainly lots of space weather news indeed. So here's Earth's magnetic moment from the ground, and yeah, the likelihood of seeing the aurora at mid-latitudes is certainly there tonight. So doesn't hurt to go out and check. We showed you some aurora in Iceland. Of course, Iceland is prime territory, one of the best places in the world to see the aurora. However, we may see some at mid-latitudes, although Monday night into Tuesday is prime time to see the aurora. Possibly all around the world. Fingers crossed for that. So KP index is currently 4.67. That's a mild geomagnetic storm condition. So kicking back up here, it looks like an early arrival of a coronal hole high-speed stream. I'll say it again. So here's the solar wind data, and you'll see we saw the solar wind density get all the way up to about 60 protons per cubic centimeter. So there's the Discover. Again, it got to 60 protons per cubic centimeter there, but it was not accompanied by strong magnetic fields. So since then, the fields have strengthened, and it looks like the high-speed portion of a coronal hole wind stream is here. So that doesn't look like a CME impact. As you can see here, the solar wind density kicked up, and then as it ramped down, the solar wind speed kicked up, along with a change in the solar wind temperature, which is this bottom pane in green. That looks like coronal hole high-speed stream there, indeed inducing mild geomagnetic storm conditions. Coronal hole high-speed stream it is. Next, the ACE, and it's showing pretty similar charts there. 60 protons per cubic centimeter. Now currently the speed is right around 500 kilometers per second. Magnetic field is weakening here. We could be seeing the trailing end there, but I would sort of doubt it. we're going to expect this one to last for another solid day or so. So lots of space weather coming in, and it's not ending anytime soon. It's an exciting time for space weather. What a great March. Maybe next one will be even better. It'll be closer to solar maximum. Well, pretty similar to solar maximum. So we should see an interesting September and March 2025 as well. Of course, September 2024 might be the ultimate. So anyway, there are goes magnetometers, and you can see some quite spiky readings there. So that is what you expect during geomagnetic storm conditions, having going on for about 2 days here. So there's the 7-day chart, and you can see the way it gets all jiggy up there in the upper reaches of the outer Van Allen belt. Next, heliosphere magnetism. And that's what's going on. For the past 4 days, Earth is in a South Pole-oriented magnetic sector. Here's our line of sight field plot. Solar B field in blue, photosphere magnetism in grayscale, and polar fields in red for south and green for north. Next, on to coronal holes. Play, coronal holes, play. So there you go, mostly South Pole oriented here, but a few North Pole there. They are not providing the magnetic sector that Earth is in. Their magnetism is reaching out south of the ecliptic plane there, missing Earth. So South Pole magnetic sector, and let's move to the SDO. There you go. There's the SDO 211 angstroms wavelength. And I'm pretty sure we're already seeing the high-speed stream from this coronal hole. So them's just the facts. Let's move on to sunspot number. Sunspot number here still around 160, and we're expecting an uptick tomorrow, maybe an uptick of 20 or even 30 sunspots. So sunspot number should be approaching 180 to 190, which is consistent with the radio flux number. So that's usually a pretty typical thing that you see there. Next is our flare probability monitor and scoreboard, and as you can see, the very high likelihood of X-class solar flares continues, especially from sunspot 3615. Now, if you saw yesterday's daily space weather video, I'm sure you noticed that we had a big giant arrow pointing to it, and the title was something like "Huge X-class flare risk" or something like that. And yeah, what do you know? It's called forecasting. It's called understanding the physics and how the data correlates. And it's just like weather forecasting, only much harder and much less intuitive, because things are going on in space with less sensors than we have for weather sensors and so on. So, but there you go. That's what's very high likelihood of large solar flares, including X-class events, continues right as 3615 moves directly into the Earth-facing portion of the solar disk there. Yeah, and we've already got an open channel. We've got the strongest proton event we've seen during the solar cycle, and there it is. So there it is. That is the strongest SEP during the cycle. So that is the highest proton density that we've seen in probably like a decade. So yeah, we even see the greater than 100 mega electron volt proton flux coming up off the floor. So not only is that the highest levels we've seen for the greater than 10 mega electron volt proton flux, I think it's the highest we've seen for the greater than 50, and I think that's the highest we've seen for the greater than 100. So that is pretty sure, correct me if I'm wrong, viewers, the strongest SEP, or solar energetic particle event, we've seen for solar cycle 25. Next, we'll cut to this is the Smash News Network. Least busted name in news. Let's take a look at sunspots. Yeah, sunspots, they're pretty good. And eyes on sunspot 3615, which is the one below our Earth scale on your screen there. Sunspot 3615 remains a beta gamma delta class sunspot group, and there is quite a bit of magnetic shear continuing, as you can see here, especially in the southern reaches of it. It is still quite unstable. It's got to resolve its magnetic field somehow, and blasting off more flares might be part of that. And remember, folks, flares and coronal mass ejections are separate phenomena, so don't get them confused. Solar flares are photons in the form of X-rays, whereas coronal mass ejections are protons, very different things. Anyway, did we miss anything here? Nope. Oh, it's time to go to flares. So, yeah, flares. They're a thing. Again, flares are photons, folks. Photons. X-ray frequency photons. And there you can see that X-class event. It was of rather long duration. And by the way, those solar energetic particles, they were moving at about 18.6 thousand miles per second. How do I know? Because they're about 1/10 the speed of light. So it takes about 8 minutes for light to get from the sun to Earth, and it took about 80 minutes for those protons to show up from peak flux. Check it out. They showed up around 4 a.m. this morning, and the peak flux of the flare was around 1:30. So about 90 minutes, something like that. 90 minutes, 80 minutes. It was 80 minutes. So that's 1/10 the speed of light, or 18.6 thousand miles per second. So anyway, let's look at flares here. There's 131 angstroms. And right at the beginning. Now keep in mind, those X-rays did come from both of those sunspot groups. However, the X-class portion of it did come from sunspot 3615. So it remains the most likely place for an X-class solar flare. It is there south of the Earth scale. And here we've put together the 131 angstroms imagery as a 60-minute running difference, and then we've got 94 angstroms, the raw data. Not half bad. What do you say? Let us know in the comments. There's a little closer view for you, as if that last one wasn't close enough. And we'll be back to look at coronal mass ejections in just a moment. But first, let's take a look at a star chart and a solar system forecast. So here are things today. Earth remains lonely on this uninhabited side of the solar system. 0 planets over here, but Mercury's making its way around. That's where things will be in 1 week. Here is our star chart. This is above our head, Lehigh Valley, Pennsylvania. That is where things are currently located. The sun in a setting mode there. And next is our astronomy photo of the day. So that's about a 60-meter wide crater on Mars. It's through some kind of artificial color or something like that, because to the naked eye this would look grayish or slightly reddish, but it looks blue for some reason because they edited the photo or something like that. I don't know, but apod.nasa.gov will tell you all about it. How does it work? Human eyes have not gazed upon this terrain, unless you count the eyes of NASA astronauts in the sci-fi novel The Martian. It's a striking shade of blue there in standard high-rise image colors. All right, whatever. I'm over it. Let's move on to CMEs, because that's certainly an important story. And check out that halo eruption. That is going to cause a major geomagnetic storm. So, yeah. And if you're in a first-world nation, your power is unlikely to go out. If you're in a non-first-world nation, well, depending on what time it is of day and things like that, of course, the power usage figures in. Your power could go out. Have battery backups and things. So here's LASCO C2 and C3. Let's get a little closer. All right, catching up. So major halo eruption there. CME impact is on the way right after a coronal hole high-speed stream subsides. If it subsides, and if it doesn't subside, we could have a co-interactive region there. Those things can amplify each other, folks. They can amplify each other. So be aware of that, because we could see an even stronger CME impact depending on especially field strength and magnetic field vertical component. The BTBZ is going to really figure into this. It's even more important than the density and the speed, because if we have a strong magnetic field, the BT, and a strong vertical component in the negative category, BZ, that could be a big deal. That could intensify both the coronal hole high-speed stream and the CME impact. Anyway, moving on to stereo A. Here are its coronagraphs and some spectacular imagery. And we'll bring that back to show you that in some great detail here after it pops off. And there it goes. Ah, man, is it a little late? What's up with that? Now we got some frames there at 323, so. Anyway, definitely a halo eruption. And let's move on to station identification. You've reached the Smash News Network, the busted name in news. There are the money shots, folks. Check it out. Synced up imagery. The SDO, the LASCO C3 in blue, the LASCO C2 in red. Just splendtacular. As more space weather heads to your back door, your front door, your side door. All the doors. And you can see some relativistic particles there striking the aperture. Again, moving at nearly around 1/10 the speed of light there, folks. About 18.6 thousand miles per second as light travels at 186,000 miles per second. So 1/10 would be about 18.6. Relativistic particles there. The strongest SEP of the solar cycle. And this one could be the strongest CME impact of the solar cycle. We have seen the KP index get up to KP8 already, though. So that was the Tamitha-Skov filament eruption. This one, I don't think it got a name. In fact, I don't even know if there was a filament 2 name there. That one looked like it just kind of came out of nowhere. Was it produced as the flare happened or just before the flare happened? Let us know in the comments what you think. There's a little closer view for you. Yowzers. That is bonkers. And here's one more series of imagery for you. Not half bad. We'll take it. Space weather on the way. And let's move on to filaments. So there are filaments from Cerro Tololo, and that's Cerro Tololo, Chile, and we've got quite a lot of filaments on the Earth's side of the disk once again. Some huge prominences in the southeast as well, so another sunspot likely to be rising down there. Look at the massive prominence down there in the lower left, your southeastern limb. And let's play that through. And then stop out on the last frame and count filaments. So I'm seeing, let's call that 1. That's 2, 3, 4, 5, 6, 7, 8, 9. About 9 filaments facing Earth once again. Likelihood of solar flares very high, folks. Likelihood of coronal mass ejections nearly 100% as well. Check it out. Instability happened with Sunspot 3615 once again. You can see some plasma motions there happening. It looks like the sunspot in the northern hemisphere there has been degrading a little bit over the past 24 hours. There we've zoomed out to show you time and date stamps. Let's move to bonus features. Satellite charging hazards are first. We've got some charging hazards there over the northern Indian Ocean and Southeast Asia there, moving toward the Central African continent. Some surface charging there, low-energy electrons building up on the outside of spacecraft. GOES electron flux here is cratered, and you can expect it to remain cratered for a couple of days before a major uptick. So, really low levels right now, big-time electron storm coming once the space weather subsides. Give it about 3-4 days, assuming no other space weather is headed our direction. We'll see a big uptick in the electron flux at the moment here at the very low levels. That's the one-year graph from Solon.info. Here is our forecast model from NOAA. The green boxes are the forecast. Here is the ionosphere, the F-flare. Feel free to pause the video on this frame. It's at 300 kilometers of altitude. This depicts atmospheric temperatures, electromagnetic radiation, and chemical concentrations. Here is the vibrational layer, the vibrational frequency of the F-flare of the ionosphere, the bridge between Earth and space, the upper part of the bridge between Earth and space. As an argument can be made that the D layer is the bridge between Earth and space. Anyway, here's the anomalygram. That's anomaly in megahertz from a 30-day median. And we'll see a little bit more red than we've been seeing. However, the geomagnetic effects have been rather minor. So, expecting them to get quite major in a couple of days. But at the moment, pretty chill in the ionosphere. There's our global ionosphere nowcast. Radio users pay attention to the right, maximum usable frequency. GPS users pay attention to the left. Huge GPS errors there expected over the eastern Pacific. Huge electron content anomalies happening there. Also high electron concentrations over the Indian Ocean. So that is typically associated with the day-night transition and the night-to-day transition. The electrons flow in opposite directions and opposite hemispheres at those times. And I'll just leave it there. Any questions about that, drop a comment and we'll talk about it. Next, we'll close out space weather with the latest intensitygram and latest magnetogram. And check it out, we got a new sunspot here that just rose in the northeast. It's pretty large too. And it also looks like it has some magnetic complexity. Also a new sunspot right here. Expecting a significant uptick in sunspot number tomorrow, assuming no groups degrade. There is our most active sunspot, our T-mass. Sunspot 3615 is a rock star. So we are seeing some major magnetic shear. And let's show you where. So right in this region, right in here, looking quite volatile, and also right up here, and also this area right here. Those are our deltas. Those are pretty volatile spots, folks. Those are all places where we could see major solar flares erupt from. So fingers crossed for that. And we're closing out space weather and moving to meteorology. So the first thing we're looking at in meteorology here are sea surface temperature anomalies and surface winds. So that's what's going on. That's the warm and cold of it for the Atlantic Ocean. So there you go. There's the Atlantic Ocean. Sea surface temperature anomaly in color scale. And then, of course, the animation is surface winds, surface wind speed. There's the Arctic. Here's the Pacific, the world's largest surface heat sink and largest body of water. The Southern Ocean's next. The Indian Ocean is next. And let's move on to wind patterns. Surface winds of the east shown here. Jet streams shown here. Jet streams of the central world shown here. Surface winds. Surface winds of the west. And the jet streams. Satellite imagery is next. how sweet it is. Satellite imagery. Oh, it's so good. So good. And people complain that we don't have enough data. That is some pretty sweet data. Fast-moving system there, making its way into Texas as we make the video. Next, our snow forecast. That's the Euro model for the next 3 days. That's the Euro forecast there, the next 3 days, the GFS forecast. Once again, Euro forecast, GFS forecast. And let's move on to our weather.gov map. Weather.gov, that's a thing. And let's scroll down to show you the key. So there's the key. Lots of gale warnings around the U.S. coastal boundaries, and geez, it's some stormy seas out there and some winter weather conditions coming to lots of places. New England and the northern plains. Also parts of California with major weather warnings. Here is the GFS 72-hour pressure and precipitation forecast. As a low makes its way toward Superior and Michigan. Next, our snow forecast. Accumulated positive snow depth change in inches, GFS 72-hour model. Temperature anomaly forecast, 72-hour GFS model. That is what's going on for the next 3 days. Next, lightning. And look at the lightning making its way out into the Atlantic. Dang! That is bonkers. And let's look for real-time strikes. Courtesy of lightningmaps.org. Yeah, real-time lightning maps. It's awesome. And we do have some activity here off the coast of Brunswick, Georgia. A whole line of strikes happening there as we record the video. Blitzoltung.org powers lightningmaps.org, so check them out as we close out with U.S. Doppler radar. For the lower 48, there's the full 50-state view. And there is the lower 48 view. Yes, forecasting the weather is too easy. So we take it all the way to space before we bring you Earth's weather. Here is satellite imagery for the lower 48. Some strong systems there off the east coast. And there you can see that moisture there being pushed aside by dry massive air. And it's getting very windy in Pennsylvania. Here's your recap, U.S. Doppler radar. These ground-based systems will depict vertical motion in the air column, showing you where the precipitation is most likely to be occurring. This space-based system shows you visible images, like what you would take if you took a black and white photograph while hitching a ride on the GOES spacecraft. Last but not least, infrared radiation emitted by water vapor. It shows you the dry air in orange, the moist air in blue. And look at that jet coming out of the Pacific. It's being directed by some dry massive air in Southern California. It's like a concentrated spray of moisture making its way from the Pacific across Arizona and New Mexico into Texas. And here's me closing out. And until next time, may that solar wind be at your back while I go back to the bunker again.